How will you bring about the following conversion? Conversion questions are very important for your exam. Very careful here. Not more than 2 steps. Maximum 2 steps. So starting material is propanol. All of you write and practice it. This is called propanol or acetone. We have to convert into propene. So let me do the procedure, dear student. First of all, I want to convert the ketone into alcohol. You know, ketone on reduction. For example, I can use NaBH for sodium borohydride. A ketone on reduction, you will get secondary alcohol, right? So what is secondary alcohol? CH3, CHOH, CH3. It's a secondary alcohol. Propanol converted to propan2ol. Ketone on reduction, secondary alcohol. Now I need propene. Propene means I need an alkene. If you want an alkene from alcohol dehydration, right? We can treat it with a concentrated sulfuric acid on heating. So OH eliminated from 1 carbon, 1 hydrogen you take from the nearest carbon, make a double bond here. So CH3, CH double bond, CH2. Yes, our compound is propene. So first reduction, ketone reduction, alcohol, secondary alcohol on dehydration, alkene. Next one, benzoic acid. Benzoic acid means benzene with a COOH, right? Into benzaldehyde. So let me write a very important reaction, dear student. Benzoic acid, let me write COOH. First, let me treat it with SOCl2. You know, SOCl2 is called what? Thionyl chloride. Or you can use PCl3, PCl5, any of the chlorinating agent. Acid converted into acid chloride, right? The OH part converted to what? Chlorine. This is benzoic acid on treated with a thionyl chloride or PCl3 or PCl5 converted to benzoyl chloride. This is an acid chloride. You know how to convert a acid chloride into aldehyde? By the addition of hydrogen in presence of palladium, reduction with a barium sulfate. Hope you studied this reaction is called Rosenmund reduction. What it is called? Rosenmund reduction. Why it is called reduction? Because addition of hydrogen. What is the purpose of Rosenmund reduction? To convert a acid chloride into aldehyde. So the chlorine converted to chlorine is replaced by hydrogen. You will get benzaldehyde. Okay, so first acid we made into acid chloride, then Rosenmund reduction, benzaldehyde. Next one. Ethanol to 3-hydroxy-butanol. Dear students, starting material is ethanol, CH3, CH2OH. But you careful about your final product. Your final product is 3-hydroxy-butanol. Your starting material contain 2 carbon, but a final product contain total 4 carbon. We studied before, that is aldol condensation. Right? So if your reactant contain 2 carbon, product contain 4 carbon, if you want to double the number of carbon, definitely you have to perform aldol condensation. But aldol condensation starting with an aldehyde, right? But this is an alcohol. Let us convert into aldehyde. Aldehyde on oxidation. So let us write the oxidizing agent. You know, it is a primary alcohol. We can use the best reagent is PCC, right? Pyridinium chlorochromate. Or we can use copper at 573 Kelvin or CrO3, anything. So alcohol converted to aldehyde, CH3CHO. Ethanol converted to ethanol. You know, aldol condensation means mix with one more same aldehyde. Hope you remember the product how to write before we have discussed. From the second compound, take 1 alpha hydrogen transfer here. So CH3, CHOH and CH2, CHO. In the first part we discussed already how to write the product during aldol condensation. Is the product right? Is the product right? Yes, student. Number 1, number 2, number 3, number 4. 3-hydroxy-butanol. 3-hydroxy-butanol. Yes. Next one, benzene. Starting material is benzene to meta-nitroacetophenone. Meta-nitroacetophenone. What is acetophenone? Acetophenone means benzene with a COCH3. Meta position, there is a nitro group. All right. How you can bring this acyl group there? Friedel-Crafts acylation. What is Friedel-Crafts acylation? Add CH3COCl. You know, Friedel-Crafts alkylation or acylation. Anhydrous AlCl3 is the catalyst. Right? So this is the electrophile. It will come to benzene ring. You will get benzene with COCH3. Acetophenone is ready. You know, it's a ketone. Ketone is a meta-directing group. So when you add nitro group, it will go to meta position. What is nitration? Add concentrated nitric acid and concentrated sulfuric acid. During nitration, nitro group electrophile will come. It will go to meta position because ketone is a meta-directing group. Next one, complete each test. This is the easiest question. Dear student, this is given as complete the reaction. Okay, maybe they're asking you the reagent or they need the product or the starting material, whatever. Here starting material is given, reagent is given. What is a compound? Dear student, when you treat, this is ethyl benzene, whatever the alkyl group on benzene ring, when you treat it with the KMnO4, see alkaline KMnO4. You know, KMnO4 is a very strong oxidizing agent. Irrespective of the number of carbon on the benzene ring, it is directly converted to carboxylic acid, COOH. But potassium is there, it will give you COO minus and K plus. So dear student, if there is one methyl group, two methyl group, ethyl group or propyl, whatever the number of carbon on the benzene ring, it is directly converted to carboxylic acid if you are using KMnO4 because KMnO4 is a strong oxidizing agent. But it is in the presence of potassium, so that actually you will get benzoic acid, but the hydrogen is replaced by potassium. It's a reactive metal. So you will get potassium salt of benzoic acid. Second question, this is a carboxylic acid treated with a thionyl chloride. We just did before in one of the conversion. When you treated with a thionyl chloride, what happened? Acid converted to acid chloride. So we can write the product as benzene with COCl. COOH, the OH is replaced by chlorine. Here also we have acid, right? That also converted to COCl. Okay, so carboxylic acid on treated with the thionyl chloride or PCl3 or PCl5, they converted to their corresponding acid chloride. Next one, C6H5CHO with this compound. Okay, what is this compound, dear students? C6H5CHO, let me write like this, okay, CHO. Okay, right? CH3CHO plus. What is this? NH2CONH is called semi-carbazide. Mostly they will try to make a mistake in the question. Okay, before when we starting the discussion of the aldehyde chapter, we discussed one of the question regarding the semi-carbazide. Dear student, when you writing semi-carbazide, please write like this. Okay, NH2NHCONH2. Please take the, we studied no. When a aldehyde or ketone coming contact with the NH2 group, this oxygen and this hydrogen eliminated as water, just club it, that's it. But when writing semi-carbazide, very careful. In semi-carbazide, there are two NH2 group. Which NH2 group we can take it? I told you before, the NH2 group which is away from the CO group, you should consider. Please don't take this NH2 group near to the CO group, okay? We can discuss the reasoning question later. So this H2O is already removed, remaining club it. C6H5, CH, double bond, here N, NH, CO, NH2. We studied before, when the aldehyde or ketone you treated with a semi-carbazide, the product is called semi-carbazone. Okay, general name, semi-carbazone. What about here? Here they given the starting material and product. What is the reagent? Dear student, here benzene is given. If you want to prepare, what is this? Benzophenone. Benzophenone. If you want to prepare this, you have to do Friedel-Crafts acylation. What is the starting material? Benzene with COCl. In presence of what? Anhydrous AlCl3. Friedel-Crafts acylation. Which is the acyl part here? This is the acyl part. It will go to benzene ring. So you will get benzene with C double bond O, then another one. Yes, this is the compound. So benzene, if you want to convert into benzophenone, the reaction is Friedel-Crafts acylation. Benzene treating with benzoyl chloride with anhydrous AlCl3 catalyst. This is a very important question, dear all. This is a benzene ring. This is a ketone, right? This is a keto group, and this is an aldehyde group. All right. And what is your reagent you're using? Your reagent is AgNH3 twice. That is our Tollens reagent. Tollens reagent. We know Tollens reagent is an oxidizing agent. It will react only on aldehyde. Tollens reaction is given by only aldehyde, no ketone. So please don't disturb the ketone. Just write as it is. Ketone is there. and you know it's an oxidizing agent, so aldehyde on oxidation you will get the corresponding acid COOH, or the ion form it's COO minus. Okay, and here CHO is there. I'm just writing the reaction once again. This is the compound given here, CHO means this one, and what is here? COOH. Okay, COOH. Dear all, it is treating with the sodium cyanide. You know, sodium cyanide which contain two ions. What are they? Na plus and Cn minus. So which is the nucleophile? Cn minus. We studied nucleophile can attack on an aldehyde and ketone. Here aldehyde is there. Please don't add into acid, okay? So nucleophile is coming and attack to this carbon. So this O becomes O minus. So let us write the product here. Here carboxylic acid, no change. What happened here all? This carbon, hydrogen, one hydrogen already there. This O changes to O minus. Alright. To this carbon, what attacking? Cyanide is attacking. Alright. And where is this Na plus? Where is this Na plus? Where is this Na plus? This Na plus, which it's coming here. Actually, you're treating NaCN and HCl, right? So, dear student, HCl is also there. Careful. NaCN and HCl actually when react, what happened? NaCl removed. Actually, the reacting species is which one? HCN, hydrogen cyanide. Okay. So, instead of NaCN, what you have to write? We have to write HCN. Okay, not this one, HCN. How dear all? NaCN when react with HCl, your product is actually the reacting species is which one? HCN. HCN contain H plus and Cn minus. Cn minus is attacking, O becomes O minus. To this O minus, this H plus will attack. Dear student, any aldehyde or ketone, when you treat it with the hydrogen cyanide, the product is known as what? Cyanohydrin. Cyanohydrin. So this is the product. Aldehydes and ketone when treated with a hydrogen cyanide, it will undergo nucleophilic addition reaction. It will give you cyanohydrin as a product. Next one, C6H5CHO. C6H5CHO is nothing but benzaldehyde. Okay, benzaldehyde CHO plus CH3CH2CHO. Okay, with a dilute NaOH. Which reaction? Dear student, here this compound, this is benzaldehyde, right? Benzaldehyde. Benzaldehyde actually no alpha hydrogen. We discussed before. This is propanol. Propanol contain 2 alpha hydrogen. Yes. So one compound without alpha hydrogen, one compound with alpha hydrogen, but the reaction is taking place in presence of dilute base. We studied before, aldol condensation happen in dilute and Kenny's arrow happen in concentrated. So let's go aldol condensation reaction. Okay, so the product will be aldol condensation. What is aldol condensation? We studied a technique before. From the second compound, take 1 alpha hydrogen and transfer into which one? Sorry, oxygen, right? Transfer into this oxygen. Okay, oxygen. From the second compound, this is a short idea. From the second compound, take 1 alpha hydrogen, transfer into this oxygen. O becomes OH. Then, from which carbon you transferred hydrogen, that carbon you make a connection with the CO carbon. So let me write the product, final product as benzene, the carbon. On this carbon, 1 hydrogen is there, right? And O changes to what? OH. Because this hydrogen when reaches here, this O becomes OH. This carbon, you have to make a connection on this carbon. Okay? CH carbon on which there is a CH3 group and there is a CHO group. This is the product. Alright? CHOH. CH3, CHO, correct. Next one, this is a secondary alcohol. So no, the alcohol connected carbon directly connected to 2 carbon. It's a secondary alcohol. CrO3 is an oxidizing agent. You know, secondary alcohol on oxidation, the product is a ketone. Secondary alcohol on oxidation, product is a ketone. The alcohol part is converted to ketone, cyclohexanone. What about here, dear student? This is a ketone, right? Cyclohexanone, treating with the O3, ozone. First adding ozone, second treating with the zinc and water. You studied that this reaction is called ozonolysis. ozonolysis process to prepare aldehyde or ketone, we are starting from an alkene, right? A alkene, on ozonolysis you will get aldehyde or ketone. So what is the alkene? We can choose it here. Dear student, let me completely write the reaction. This is a cyclohexane ring, right? And this is a double bond, one another cyclohexane ring. You see, they have 2 molecules of cyclohexanones, 2 molecules. So this is the alkene I want to select. What is ozonolysis? First we will add ozone. Second we will treat it with which one? Zinc and water. Lysis will happen. Very easy to write the product during ozonolysis. Break the double bond. Okay, on the alkene, break the double bond. Why I selected this alkene? Because they need 2 cyclohexane ring, dear all. So therefore I selected this one. Okay, so cut the double bond, 1 oxygen on this carbon, 1 oxygen on this carbon. Yes, your product is ready now. What is your product? Cyclohexane with a ketone with one more compound. So total 2 molecule will get it. Right, and practice it, everyone. Next one, let us go to the reasoning question. Give possible explanation for each of the following. Cyclohexanone. Okay, what is cyclohexanone? This is the one. It forms cyanohydrin. What is cyanohydrin? I told you, when you treated a aldehyde or ketone with HCN, H plus and Cn minus is there. The Cn minus is the nucleophile. It will attack to this carbon, because we said no, this carbon having a partial positive charge, this oxygen having a partial negative charge because of the change in electronegativity. So nucleophile always try to prefer the carbon, and this O becomes O minus. So product, let me write it here, all of you. This cyclohexane, O changes to OH, because this O minus, this H will come, and on this carbon cyanide is there. This compound is called cyanohydrin. So any aldehyde or ketone, when you treat it with hydrogen cyanide, the product is called what? Cyanohydrin. All right. This reaction is very high in cyclohexanone, but what they are saying in good yield, but 2,2-dimethyl cyclohexanone. What is that compound? This is cyclohexanone. This is the second carbon having 2 methyl group. Okay, 2,2-dimethyl cyclohexanone does not. This reaction is very weak. We studied before in one of the question. Dear student, you are adding the compound here HCN, hydrogen cyanide. In hydrogen cyanide, Cn minus is the attacking species, that is a nucleophile. Whether aldehyde or ketone undergo nucleophilic addition, we discussed before, aldehydes are more reactive. Here, because both are ketone actually, but right. So what is the factor affecting the nucleophilic addition? Here here in this compound, Cn minus attack is so easy, but here it is difficult. Why? Dear all, you know this compound contain methyl alkyl groups. That is the only difference, right? Cyclohexane, this one. You know, it is a donating group. Alkyl groups are donating group. If there is a donating group, what is the problem actually? If it is a donating group, it will donate electrons towards this carbon. Actually, I told you this carbon having a positive charge and negative charge. If cyanide is, the nucleophile is waiting, it is trying to attack on this carbon. When the Cn minus can attack on the carbon so fast, if the carbon having more positive charge, correct? But here, it is a donating group, dear student. If there is a donating group in the system, they will give more electrons towards this carbon. Electron is with a negative charge, right? So the positive charge will decreases. Reactivity decreases. So this is the point. Nucleophilic addition reaction happen in aldehydes greater than ketone, because aldehyde contain less alkyl group, donating group, ketone contain both side donating group, right? So here cyclohexanone not having a specific donating group, but 2,2-dimethyl cyclohexanone having 2 alkyl groups. Alkyl groups are donating group. Donating group will decrease the reactivity of the aldehyde and ketone towards nucleophilic addition. Nucleophile cannot attack if there is a donating group, because the positive charge on the carbon will decrease. This question we discussed many times before. Let me complete the point here. There are 2 NH2 group in semicarbazide. Do you remember, dear student, what is semicarbazide? NH2, NH, CO, NH2. This is our semicarbazide. However, right, this is NH2, NH2. Yeah, there are 2 NH2 group in semicarbazide. However, only one is involved in the formation of semicarbazole. Right, when we treating with a aldehyde or ketone with this one, I told you which NH2 group you should consider. Which NH2 group do you remember? The NH2 group which is away from the CO group. It is involved in reaction. This NH2 group involved in the reaction with aldehyde or ketone to get semi-carbazole. But this NH2 group, please don't take it. Why? On this nitrogen, there is a lone pair. This lone pair involved in resonance. Let me draw the resonance structure here. Okay, you can able to understand, right? This bond become double bond, this become single bond, oxygen carry negative charge, right? So the NH2, why we are not taking, even though there are two NH2 group in semi-carbazide, why we are taking only the NH2 group which is away from the CO group? Because the NH2 group which is near to the CO group involved in resonance. It is involved in resonance. So is this NH2 group available for the reaction? No. So please take, if they given a semi-carbazide, the NH2 group which is away from the CO group, because here resonance is not possible. So this NH2 group is available for the reaction. Next one, during the preparation of ester, ester is prepared by the reaction of generally a carboxylic acid reacting with a alcohol in presence of a acid. HCl like that, and it is a reversible reaction. Esterification is a reversible reaction. During the preparation of ester will form along with the elimination of water. This is esterification. During the preparation of ester from carboxylic acid and alcohol in the presence of an acid, the water or the ester should be removed as soon as it is formed. What is the reason? Let me come to the point. This is esterification, acid reacting with alcohol in presence of a mild acid like the catalyst HCl or something, strong acid. It will give you ester and water. What they're saying, during this reaction, whenever the ester, water or form, you have to replace from the system immediately. Why? Dear student, the main reason is this is a reversible reaction. Esterification, hope you can note that I'm not writing. Esterification is a reversible reaction. Therefore, I represent by double-headed arrow. Suppose more ester form, more product form in the product side. You studied in 11th grade Le Chatelier principle. This is a reactant, this is the product. If more products form, means ester or water formed more in the system, in order to compensate the equilibrium, reaction shift backward. Yes or no? If products are greater, reactants are lesser. In order to balance them, backward reaction will happen. If backward reaction happen, what is the situation? Your ester concentration will decrease, means the productivity decreases. Esterification means formation of ester, right? So what is the reason? The question is this one. During esterification, why this water or the ester should be removed as soon as it is formed? Okay, so when this acid reacting with this alcohol, when ester formed, dear student, whenever ester form, please remove water or ester from the chamber immediately. Then only product side will be lesser, reactant will be greater. This forward reaction will continue. Okay, so esterification is a reversible reaction. When ester formed along with the water, more ester and water on the product side. So what happened? In order to balance it, backward reaction happen. That will decrease our productivity of ester. So whenever ester or water form, please try to replace both of the component immediately. Then forward reaction we can keep it for a long time.
Brilliant, Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant, Qatar.